Hello and welcome to Tribe Topper. In this video session, you are going to learn about electric power. We know that whenever an electric charge Q is moved from one point to another point, there is a potential, and that happens when there is a potential difference V between those 2 points, then work is done, right? So we move a charge or any charge, electric charge Q or electrons from one point to another point. Whenever a potential difference exists between those 2 points, then work is done to move that charge, and probably you remember that that work done would be equal to Q times V. So what is power then? Basically, in how much time we do that work, that is power. So you can simply define power is the rate of doing work. So you can say power is equal to work upon time. And as per the formula, I would mark it as 1, that W is equal to QV. So can I say that P is equal to Q times V over T? I have replaced W as QV. Now this gives me that therefore power is equal to what? What is Q by T? Q by T, if you remember, is the rate of flow of charge, which is current. So I would say power is equal to I times V or VI. So one expression you have is work over time or V times I. Now here in this expression only, if I use Ohm's law, so if you remember that by Ohm's law, V is equal to IR. Therefore, the power would become what? I times V, and the value of V is IR. So it becomes I square times R. And another expression you can get same way from Ohm's law, that I is equal to V by R. So if here you plug in the value of I as V by R, the power which is VI becomes V times I as V by R. So you have an expression for power as V square by R. So we can say that the expressions of power can be work over time, or VI, or I square R, or that is equal to V square by R. Now, which formula you are going to use, that would depend completely on the question, the information given, and the situation. So let's have a look at a question here. So we have a resistor of resistance 12 ohms, has a current of 2 amps flowing through it. How much energy is generated in the resistor in 1 minute? So first of all, let's write down all the information that is given to us. That resistance R is equal to 12 ohms. Current I flowing through the resistor is 2 amperes. So therefore, what should be the power? We just learned the formula for power as I square R. So because we have I and we have R, so we should definitely use this formula, I square R, which gives me 2 square times 12. So we get 48 watt. But this is the power. The question asks us how much energy is generated in the resistor in 1 minute. So from the formula, that power is work over time, and from mechanics you have always learned work and energy are interconvertible. So I can also say it's the rate of consumption of energy, or rate of doing work would mean rate of consumption of energy, so or generation of energy. So energy over time is also the same thing as work over time. So from that we get energy generated would be power into time. Now the power of our generator is 48 watt, and in 1 minute how much energy will be generated? So 48 watt into 60 seconds, because time has to be in seconds, and multiplying this we get 2.9 into 10 to the power 3 joules. So you have another formula that you must remember, that if you have to find out the energy, that will be power into time, because work is replaced by energy here. So power can also be E by T, that's energy over time. So energy that has to be calculated will always be power into time. Okay, so let's have a look at the next question, that a light bulb rated as 60 watt at 220 volt has a potential difference of 110 volt across its ends. Find the power dissipated in this light bulb. So here we are given that a bulb which is rated at 60 watt and it is supposed to operate at 220 volt. So if it is operated at 110 volt, then what will be the power dissipated in the bulb? So what we can do is that we know the power, we know the voltage. So let's find out the resistance of this bulb first of all. So using power is equal to V square by R gives you that R is equal to V square upon P. So we get R is equal to V square, that's 220 square upon the power, which is 60. And solving this we get 806.7 ohms. So that's the resistance we get. Now the resistance of the bulb will not change. That is fixed. So if now the same bulb which is operating at 110 volt and its resistance is 806.7 ohms, then what will be the power dissipated in this bulb? So we'll say therefore the power dissipated now would be again using V square by R, but this time we know V square and R gives us 110 square by the resistance 806.7. So we get the power as 14.99, which you can write approximately as 15 watt rounded figure. So what we have done here is we knew the power and power rating and the voltage. So we found out the resistance. So when you change the voltage, your resistance is not going to change. So if you've reduced the voltage to 110 volt, then what will be the power dissipated? So first we find out R using V square upon P, and then using this R, we find out power using V square by R. So that's all in this video session. In the next video session, you are going to learn about the combination of resistors in series and parallel. Thank you.